Welcome to clickmeproject.com. Let me discuss about the process, a segmentation and graph-based sequential matching method for video copy detection. Let me see the execution of the process, a segmentation and graph-based video sequence matching method for video copy. The input videos are converted into frames and pre-processed. Shifty features were extracted for all the frames of the videos. The shifty features extracts the edge information from the image and the values were saved as features. Then the shifty feature is extracted for the input query frame that we are giving. So the minimum distance, equivalent distance is calculated between the test images and the train images. So the frames that have the minimum distances are collected and the frames corresponding to that ID were got and they were displayed. So the frames that are similar to the input frame that we have given were retrieved from the database. So in this process for pre-processing we are applying Gaussian filter. Gaussian filter smoothes the video and makes all the pixels in the images more clear. For feature extraction we are using shift algorithm. So shift algorithm detects the local features in the image and extracts the edge informations. Then the equivalent distance is calculated between the test image feature and all the train images features. Finally, the ID of the frames were got and the images that have the name as the ID in the database were taken from the training database. The retrieval of the images from the training database is done in a sequential order. The retrieved frames will be in sequence so that the frames continuous from the given query images were retrieved. Let me see the flow of the process. Initially, the videos were collected and they were saved and all the videos were converted into frames. Precious bits were wasted on a noisy video, so we are applying pre-processing process. Here we use Gaussian filter in order to remove the noises from the frames. This will smooth the video and make all the pixels in the images more clearer. For applying Gaussian filter, we have to use InFilter function. Then we are extracting the shift feature for all the images in the database. Scale invariant feature transform is an algorithm in computer vision which detects and describes the local features in the image. It has many applications. Mainly here we are using shift feature to extract the edge values from the input frames. Then the query frame is pre-processed. Here also we are using Gaussian filter and then the shift features were extracted and the test image features and the training image features were equivalent distance between the test image features and the training image features were calculated. The equivalent distance between the test image and the train image features were calculated and they were ordered in an ascending order and they were sorted in an ascending order. The two frames that are more similar consist of the low equivalent distance and they will come in front of, since we are sorting it in the ascending order. So the images that have the minimum equivalent distance were retrieved from the dataset that we have given. So the ID of the frames were got and the images that have the name as the ID were taken from the training dataset. The retrieval of the images from the training database is done in a sequential order. The retrieved frames will be in sequence so that the frames are continuous from the query images were retrieved. Let me see the execution of the process. If you want to run the code, select the file main.m which is located in the source code folder. Right click it and click on run file. You will get the user interface which is required to run the process. So first click on load video. So the videos that we have collected were converted into frames and they were saved in the folder. Then training features were extracted. So for all the frames in the videos, the shift features were calculated and they were saved in the table format. Then you have to give any one of the input frame. So for that we have given this frame. So initially the frame is loaded and it is pre-processed. Then the features were extracted for the input frame. The extracted features were saved here, will be saved here. Here the features were saved and then the frames related to the input frame will be retrieved using equivalent distance calculation. So here the frames similar to the input frames were retrieved. Like that, you can give any other query image, the similar frames will be retrieved. So we have to extract these features, and then the similar frames were retrieved as the input frame. So like that the process is going on. So initially, thus we have produced a process which extracts the similar frames as the input frame given. Thank you.